So with our sine and cosine functions, so we're starting out with our sine function here, and we're basically saying, obviously you can see, what kind of function does this remind you of? Have you seen this kind of function before?
Is that cosine or sine?
So this one's the sine. The second one on your page is cosine. So for what application do you normally see this kind of a graph?
Frequency.
Frequencies, yeah, even sound waves, right? So that's basically what the application for these functions. Now, the one thing you should notice let me see if I can get both those graphs on the same page. What are you noticing as a difference between your sine and cosine functions?
Where they start.
Yeah.
One starts at 1, the other starts at 0.
Yeah, so you will notice that the sine function actually passes through the origin, right? So your x and y intercepts are going to be at the origin, but for our cosine function, we're not passing through the origin, we're actually passing at +1 on the y-axis. So you can see, obviously it's being two different functions, you're going to see two different features from that. So just kind of that description, you can see at the top, we're saying the black portion of the graph will represent the one period that we talked about in the previous sections. So you can see for both sine and cosine, our period is 2 pi, but you will notice we're starting at 0, 0, right? We go through basically this one wave, right, which gives you the pi, and then coming down and finishing it up at 2 pi. So this is what we call one period, and then of course you know that keeps repeating as you go towards positive and negative infinity. You should also remember that we talked about domain and range for both these functions, and the domain is negative to positive infinity for both functions, right? So we know this graph is basically going to keep going endlessly as far as the x-axis is concerned. Now, when you look at the period for the cosine function, of course, you will notice we're starting at +1 here. We go all the way down to -1, and then we complete our period. So as far as that period for both functions goes, you're actually making the same journey, but you're just starting at different points, right? You start at the x-axis and you come back to it, whereas with the cosine function, we're starting at +1 and we come back to a +1 in that case. Okay. They're talking about, let's see. Oh, the gray portion of the graph indicates the basic sine curve repeats indefinitely from left to right, so that's going to be on top of your domain. Okay, what can you tell me about the range for these functions?
1 and 1.
Yeah, 1, -1, right? So we're not going to be going beyond those values. And think about in terms of the unit circle. In terms of your y value, we stay between 1 and -1, don't we? If you look at it in terms of your unit circle. So that's the same thing you're going to notice here in the range of both your functions. And then you can kind of see some other features of these graphs that we're bringing in. So we're saying that for figures 1 and 2, that the sine curve is symmetric with respect to the origin, and we know that's true because we know the sine is an odd function, right? And all odd functions have symmetry with respect to the origin. Now, on the other hand, we know that cosine is an even function, so cosine being an even function should have symmetry with respect to the y-axis right there. Okay, so the same thing that we talked about in college algebra, you should be noticing those same things here with your sine and cosine functions. And then of course, the 5 key points, this is something we're going to need anytime we are graphing any variation of our trigonometric functions. So we need to know, of course, where our graphs are going to have their intercepts at. We need to know what the maximum points and minimum points are going to be. So if you notice here, this is our sine functions. Of course, we have the intercept at 0, 0. when we do half of our period, we come back to the x-axis. So you're actually going to have another intercept at pi. And then completing that one period, you are back at 2 pi, right? So those are your intercepts. And then your maximum value, of course, is going to represent your upper range value, right? So that's going to be at +1. And then, of course, your lower or minimum value is going to be at -1. With a cosine function, of course, our maximum value is also going to be our y-intercept, right? So that's going to be at +1. But then your intercepts are going to be at different places because you're basically moving your graph a little bit over. So you're going to be at pi halves and 3 pi halves for your intercepts. And of course, your minimum values are going to be at -1, positive values at +1, or maximum values at +1. So let's take a look at, if you have a function like this, how would we calculate these key points and help us come up with a graph? So we're looking at basically just 2 times sine of x. Now you guys should remember transformations that we had done in college algebra. So do you remember what that 2 will represent? Say that one more time. Yeah, it stretches it, right? So the same properties here with trigonometric functions, and they're actually asking us to stay within this interval, right? So they're saying go from -pi to +4 pi.
Yes.
Oh, and this doesn't let me do that. All right, so as Jose mentioned, we are going to have our 2 times values of sine of x, so everything basically goes by 2. So you've got your x-intercepts at these positions, and then what are we noticing between the maximum and the minimum ordered pairs?
Further away.
Go ahead.
They're further away.
They're further away, right? Because instead of having +1 and -1, your y values are now +2 and -2, right? Because you're basically taking that -1, +1 that we get from the sine x function, and you just multiplying 2 with that, which is now giving you a wider, like you said, it's going to stretch your graph. And you should notice that, man, I don't know why it doesn't let me do that. So look at, just with that having 2 in front of our sine of x function, look how that graph changed, because now you're getting more height on your waves than you would with the sine x function. And okay, this is what I was talking about. So you're only drawing your graph within these x values. So you're going from -pi all the way to 4 pi, and that's the only piece you're drawing, right? You're not drawing anything else outside of that, because these guys keep going forever, basically. So we're going to do the same thing with the cosine function. So they're giving us y equals 2 times cosine of x, and they're asking us to stay within the interval of -pi halves to 9 pi. So you can basically use the values that you have from your cosine of x function, and you're basically multiplying the y coordinate by a factor of 2. So looking at our maximum, what do we have? Intercept, minimum. We should be at an intercept again. So we are going from a transition of maximum point to the intercept on the x-axis to the minimum to the intercept. So what should we be at next? And you can go and look at your cosine graph. How does that period work? Yeah, you should be ending up back at a maximum. Like I said, you can use that graph you have for the cosine function and use that as guidance. So what is your first maximum point that's given to you?
2 constant.
So close.
Zero.
Yeah. Oh, where's my example? Okay, let me see if I can go back to that guy. Okay, so every ordered pair that you're seeing in this little graph here. So remember what I said, we started out with the maximum, you go to an intercept, minimum, and intercept again in maximum, right? So each of these y coordinates that we are seeing for these ordered pairs are going to get multiplied by 2, because all we are doing is instead of y equals cosine of x, we are doing 2 times cosine of x.
So only the y-intercept, y.
Y values will change. Because for your x values to change, we would have had cosine of x, but then you would have x in parentheses with plus or minus something if your x values were going to change. So since we're not really doing anything horizontally, this is just your vertical stretch that's happening here. Okay, so first point in the cosine function would be 0, 1, right? But we're multiplying the y coordinate by 2, so 1 times 2 will give you 2. What's our first intercept that we run into? Pi halves over 0, right? So pi halves will stay the same. And 0 times 2 will be 0, right? So that means your intercept is actually not going anywhere. It's going to stay at the same point. Now, where were we at a minimum in the original function at?
0, -1.
0, -1. So if I take -1 and multiply by 2, -2, so 0, -2. Will our next intercept value change? 3 pi halves and 0? Because 0 times 2 will again be 0. So this intercept again is at the same place. And what is our next maximum value going to be? The original was 2 pi and 1.
2 pi and 2.
Very nice. 2 pi, 2 will become your ordered pair for the next maximum. All right.
So when we do these, do we actually have to sketch the graph, or do we just put the intercept? These like.
So, you know, on the exam, of course, you need to sketch the graph. I would imagine
Sketch the graph for this
Web Assign is probably having you do something, probably on a grid or something, right?
Okay, so
So, all right, we're gonna have our,
we have to draw like the original 1, 2, or just like.
if you wanna do a comparison, you can, but we're obviously only looking for the final graph. Okay, so in this case, we're actually going to do our y-axis in the middle, and then, oh, I probably wanna make this guy longer. Okay, and they're actually asking us to go from negative pi halves. So this here, let me see if I can make this guy a little skinnier. Negative pi halves. You're going to have, of course, this is the origin, so that will be your 0, 0. We will be at positive pi halves, right?
Yeah.
What will be our next coordinate?
pi
Pi.
and 3 pi over 2. And then 2 pi.
Very good.
And then just 5 pi over 2. 3 pi.
And they're asking us to go how far?
Up to 9 pi 2.
Okay, so this is not going to work for me, is it?
It's a big one.
It is a big one. I should have. Okay, I'm going to use a really skinny line, and I hope you guys can see that already.
Or calibrate.
It just doesn't want you to write.
No, and every time they do some kind of update, it starts acting funny. But they just updated the software. I think this morning is what Ryan said. Okay, so we only need negative pi halves here. And we need 1, 2, 3, 4, 5, 6, 7, 8, 9 on the right. Okay. Pi halves, pi, 3 pi halves, 2 pi, 3 pi, 7 pi halves, 4 pi, and 9 pi halves.
So why do you go so far?
Because they're specifically asking us in the example to go from negative pi halves to 9 pi halves, so we have to make sure that we extend our graph accordingly. Now, you know, the idea is if you can get these 5 points, and we know these functions have that period which keeps repeating itself. So if once you get this pattern down, then you can actually extend it for however long they want your graph to be. So we are starting at our maximum. Let me get my 1 and 2. You know, I hope you guys can get a better graph than what this guy is doing up here.
Oh, no.
Yeah, the calibration is completely off at this point. There we go. Better than before, I guess. Alrighty, so you are starting at 0, 2 with our maximum point, right? Then at pi halves, we are running into x-intercept at 0, negative 2 coming down here. We're at our minimum intercept at 3 pi halves, and then maximum at 2 pi and 2. So what should our next value be after a maximum? You're at an intercept again at 5 pi halves. At 3 pi, you're going to be at a minimum. Intercept again, 4 pi, maximum, and at 9 pi halves, intercept. Okay, now going backwards, if you're at a maximum here, so kind of think you're going backwards from here, what should be my next point after, and or before a maximum? Intercept, and where's that intercept going to be at? Pi halves, yeah. Negative pi halves, which that distance is not even. So you're basically going and making your little wave of the cosine function. And then that guy should be closer, but hopefully we can get a little bit of a decent shape out of this. So it should look like your 2 times sine function here, but obviously your x and y intercepts are going to be in a different location. So you should kind of have that height on there, which would be a little bit different. Now, if I were to superimpose, let's say, our basic cosine function in this case, then that guy would be going from here to here.
So wouldn't the minimum be pi negative 2?
Your minimum would be at 0, negative 2. No, yeah, that should be pi. Why did I put 0 there?
Yeah, because on the original.
Yeah, because that's this point here.
Yeah, I got
The
confused.
0, negative 2 would be here. Yeah, thank you. No, that is the wrong point. Yeah, this guy should be pi Okay, so in green, you have the cosine function, and then in red, we have the 2 times cosine of x function. So in this case, then how does the range of your function change?
The range goes from -1 or 1 to 1, it goes from -2 to 2.
Yeah, so for the 2 times cosine function, you are going to be going from, and what kind of brackets, parentheses do we use?
Um,
Parentheses or brackets?
Is it brackets?
They are brackets because you actually do have points at -2 and 2, so you are including your endpoints in this case. Okay, so I know this is a very basic example, but do you have any questions on this guy so far? Now let's see what happens if we look into the amplitude and period for these guys. So here, of course, again, go back and think about the transformation of functions, if you will. So we are talking about you have y equals d plus a times either sine or cosine function, parentheses b times x minus c. So of course, x is your variable, right? Or your angle, whatever you want to think about it. But then you've got transformations coming in the form of the variables a, b, c, and D. So again, if you wanted to kind of go refresh your memory, if you have your notes from last semester, that's fine, or you can look at P8 to kind of refresh the different transformations. So remember, we've got horizontal translations that moves your graph left and right. You've got vertical translation, which moves the graph up and down. You will have a horizontal stretch and shrink, and you will also have a vertical stretch and shrink. So just some definitions here. We're talking about the constant factor A that you're multiplying in front of your sine or cosine factor, which is what we're calling as the vertical stretch or shrink. Remember again, if the value of the A variable is going to be greater than 1, then your function will stretch. If the value is going to be a fraction or a decimal between 0 and 1, then your curve or your graph is going to shrink in that case. Do you guys remember what happens if you have a negative on this A variable?
Shrink.
No, the shrink comes from the value if it's between 0 and 1.
Oh, inverse. Like flip your Rooney, what is it?
Reflection.
Yeah, there you go.
I was hoping you'd eventually get to it. But yeah, so the negative sign in front of A would just basically mean reflection. And so again, we're talking about based on what that A value is, the range of your function is actually going to change based on that A value. So you will go from negative A to positive A based on whatever that is. So the absolute value of A is what we call as the amplitude of your function in this case. And again, they're kind of talking about the range. Again, so just as a definition, we are saying the amplitude of y equals A times sine of x or y equals A times cosine of x will represent half the distance between your maximum and minimum values of the function, and amplitude is given as absolute value of A. So we're kind of looking at this example here with our vertical stretching and shrinking. So they're saying in the same coordinate plane, they want us to sketch the graphs of these two functions, 1/2 cosine of x and 3 times cosine of x. So basically just a variation of the 2 times cosine of x that we just did, right? So in this case, of course, that means all our y values will now need to be multiplied by a factor of 1/2 for part A, and for the second one, it would be multiplying them by a factor of 3. So again, you should notice how those y values are changing in the maximum and minimum ordered pairs, because now instead of having 1, these guys are going to be 1/2 and negative 1/2. And then of course for the 3 times cosine of x, your maximum and minimum values are now going to have 3 as their y coordinate, and then you can kind of see what this graph ends up looking like. So the gray function, or I guess on your paper it would be the lighter out of the 3, is the original cosine function. And then we've got the higher amplitude, right, with the 3 times cosine of x function, and you have just about a shallow amplitude with that 1/2 cosine of x function. And I know you guys had used frequency as an example. So how does amplitude work with frequency?
Is like how, like how big the things are, is that correct?
Yeah.
And then frequency is just how often they are varying.
Yeah, very good. Yeah, so the amplitude is basically talking about what those height of your waves are going to be, right? How steep, I guess. I'm not sure if I want to use the word steep with amplitude here.
Tall.
How tall? Yeah, they're definitely giving you that height. Alrighty, so we are replicating that now using the sine function. So we are doing this with 1/3 sine of x and 3 times sine of x. Okay. So for part A, it's 1/3 sine of x. So again, we need our 5-point summary. Where does a sine function begin?
Zero.
Yeah, it starts at 0, 0, right? So we are actually going to start at the intercept. And the idea is now the y coordinates get multiplied by 1/3, right? So 0 times 1/3 will of course still be at 0. What's the next you have from an intercept in a sine function?
Pi comma 0.
So maximum or
Oh,
minimum?
wait, which one for the max?
Max.
Are we talking about maximum?
So for a sine function, we start with the intercept, and where do we go? Do we go up or do we go down? Yeah, we go maximum. So our next point will be a maximum point. At which x value? Yeah, 5/2. Yeah, so in a sine function, that's plus u, 1, right? So you're multiplying by 1/3 and 1, you're going to get 5/2 at 1/3. We should be going back to what point after the maximum?
Our intercept.
We should be going back to an intercept, and this is going to happen at which x value? At pi, and of course it's an intercept, which means you're back at 0. We have a maximum, which means our next point has to be a minimum. And what's the x value for this guy? Yeah, 3/2, very nice. And our y coordinate for that?
-1.
-1/3, yeah. Which means we are now back at an intercept. And what is this x value? Yeah, we should be back at the x-axis, so this is 2 pi and 0. Now, before I actually do the graph, I'm going to create the 5-point summary for our part B also, so we can graph them on the same plane. So that is 3 times sine of x. And obviously the order of the points will be the same, right? We start with the intercept again. And what will be the coordinate for this function? Still at 0, 0. Maximum?
Pi over 2 and 3.
Yeah, pi over 2 for the x and then 3 for our y coordinate. Intercept will be at the same point again. So pi and 0. What will be your coordinate for the minimum?
3 pi half and 3.
3 pi halves, and you said -3, right? And then you're back at the intercept again, which will be at, so you can see your intercept doesn't change, right? Even if that amplitude changes, it's just going to be the y coordinates on your maximum and minimum points, which actually reflect that change that happens. Okay, so let's see if we can get these points. They didn't really specify an interval that they wanted to graph this on. So normally in that case, we just go from 0 to 2 pi, which gives you that one period, right, for your function. So in this case, let's say we're starting at 0, pi halves, pi, 3 pi halves, and 2 pi. Is it good?
Yeah, I put smartboard on it.
No. Oh, no, I have to work your codes to get the internet to work on this. Yeah,
Perfect.
thank you. All right, so we are starting at, and you know what, I'm actually going to draw our sine. So I want you to see how that changes. So we will be going from, that 1/3 is going to be the interesting one to try and graph. So let's say we have 1, 2, and 3. 1, 2, and 3. So your basic sine function would again start at 0, 0, go up to 1, x-intercept, go.
So on the exams, we don't need to draw the base one,
No,
just a new one.
just the function you're looking at. This is just me actually showing you the comparison. And we're just doing one period here on our graph. So in black is the basic sine function. And then let's do our 1/3, which would still be starting at 0, 0, same x-intercept, but now it's going to be very shallow, right? That curve. So you are looking at 1/3, which would be about here and maybe about here. Maybe something like that. Okay. And in red is the y equals 1/3 sine of x, and then let's do 3 times sine of x in green, and that's going to +3 here and -3 here. Same x-intercepts. Having the shadow of your hand fall when you're graphing does not help you at all. But hopefully this still gives you an idea of what those graphs are. Hopefully you can get a more better looking graph on your handouts than I can up here on this guy. Okay, so questions about, obviously we're only working with amplitudes right now. Questions about that? And of course we're going to be looking at how all of those different transformations make a difference to your graph. Now, remember, if they ask you to increase the range of where you're graphing this, you are basically trying to replicate that pattern. So I always do my 5 key points from 0 to 2 pi, and then depending on how far they want us to go on the positive and negative side, you need to replicate. And you can see there's a pattern to both our graphs. They're always going to alternate between your maximum intercept, minimum intercept, maximum, right? The only thing is, with a sine function, you're always going to be starting at the origin, so that's your intercept at 0, 0. And where did the cosine function start at? Instead of 0, 0, 0, 1, yeah, so it's going to start at the maximum on the cosine function. Okay, what do we have next? Reflections? And what did you call it? You called it something else.
Arrays.
Yeah. Okay. So just an idea of, so what do you think will happen if you are given, like here, your 3 times cosine of x and negative 3 times cosine of x? How do you make that change happen in your graph?
It probably just change really where you start and then just how you back it out the rest of the way.
So with your ordered pairs, what would you end up doing?
So instead of like 0, 1, it would be 0, -1.
Yeah. So honestly, the only thing, again, we had kind of talked about this in algebra, but the idea is change the sign on your y coordinates. So positives will become negatives, negatives will become positive, and that's how you're actually changing and getting the reflection of a graph. Because think about it, on the original function, this point right here is 0, 3, and in that reflection, that became a 0, -3. So you're literally just interchanging your signs on the x and y, sorry, just the y coordinates. Now, in terms of that b variable, b variable is going to represent the, well, it's actually going to help you come up with the period of your function, but basically the idea is like a represents the vertical stretch or shrink, b is going to represent the horizontal stretch or shrink. Again, the idea is if the value is greater than 1, you should have a stretch. If the value is between 0 and 1, you should have a shrink. So just okay, so they're just talking about in terms of, think about the positive real number b, what kind of effect it's going to have on your graph. Your one cycle of your graph for sine of x goes from 0 to 2 pi. Well, that cycle is actually going to change because we are defining the period as being 2 pi over b. So the idea is when we do y equals a times sine of bx, you're actually now, instead of going from 0 to 2 pi, you will go from 0 to 2 pi over b. So you're actually going to have to take this variable b and divide it into 2 pi, because remember, sine of x, or for that matter, cosine of x function, the period goes from 0 to 2 pi. But if I'm going to bring this variable b in, the period of that specific function is going to change. So it's going to shorten depending on what the value of b is. So to find the period of those functions, we have to remember 2 pi over b. And again, like I was saying, they're talking about when the value of b is between 0 and 1, the period of your function will end up being greater than 2 pi, and then that will represent a horizontal stretch. If your value of b is 1, then of course the period will be less than 2 pi, and that also means you're going to end up in a horizontal shrink for your graph. So looking at, I don't know why it doesn't move anymore. They're actually using the idea of odd and even functions here again if b ends up being a negative value. So that's something we'll look at when we get through our examples. So here you can see, of course, our amplitude is just 1, right? So we're keeping that amplitude the same. But now they're asking us to figure out what the graph of x over 2 will look like. So the idea here is, remember, you're multiplying b into x. So you have to figure out what that value of b is. So if you take that x to the side, you're going to get 1 over 2 as your b value. So since b is 1/2, you are trying to figure out what the period of this function is. That's where you take 2 pi divided by b, 2 pi divided by 1/2. You invert that 1/2 and multiply by 2, right? So that's where you're getting that 4 pi from. So this is what they were talking about. If your value of b is between 0 and 1, the period of your function increases, which also means that these values are actually going to change now, right? Because your period has changed. So your maximum, minimum, your key points are going to change. So in this case, we are taking our interval, which will now go from 0 to 4 pi, and we're breaking it up into 4 equal parts. So that means our x values are now going to be at 0, pi, 2 pi, 3 pi, 4 pi, right? So you can see how these x values have changed. Our amplitude is still between 1 and -1. So your x values are anywhere from those two numbers. So changing the period will change your x coordinates. And then of course you can see what that graph ends up looking like, right? Because we're increasing the period, which means you are horizontally stretching your graph, right? So that interval is now going to become longer. So instead of intersecting at pi, well, that should have been pi halves here, you're obviously extending this graph out, and you can see how that guy's going to end up stretching. And then keep in mind this thing here. And this is our general rule when we are working with any of these sine cosine functions. Your interval for the period is always going to be divided into 4 equal parts. So once you figure out what the period of your function is, we always end up dividing by 4. And then they're saying you're starting with the left endpoint. So in our function there, you went from 0 to 4 pi, right? So your first left point would start at 0, and then 4 pi divided by 4 ended up giving us pi. So you went in increments of pi. In this case, they're using the example of negative pi over 6 to pi halves. So you basically figure out what that distance is going to be, right? And how do you calculate that distance? The distance from negative pi over 6 to pi halves.
Subtract them.
Yeah, you end up subtracting them with which in this case, since this is a negative number, you actually end up adding them, right? Which will give you the total distance of 2 pi over 3. And then again, you're breaking it up into 4 equal parts, so that tells you what your x values are going to be. So in this case, your least x value would start at negative pi over 6, and then you would basically keep adding pi over 6 to it till you got your 5 points. And so that's something, yes, we can do that today, but that's something we're going to need to figure out with this graph here. All right, so again, start looking at homework for 1.5. And if you get a chance, try working through this example 3, see how much you're able to do on your own. And if not, then we'll definitely start with example 3 next time. Okay? All right, guys, this is a short week, so have a wonderful week. I will see you on Tuesday. Let me just stop this and I'll come over.
Okay.